Have you ever just looked up at the night sky and felt that sense of wonder and maybe felt a little bit small? Well, that's what we're going to dive into. We're going to connect the dots from the actual Big Bang all the way down to the ground in your own backyard to really map out our place in this incredible universe.
So here's our game plan. We're going to start with the ultimate origin story, where it all came from. Then we'll take a little tour of our local neighborhood, the solar system. After that, we'll zoom right in on Earth to see how these huge cosmic movements create our seasons. And finally, we'll get into the fun stuff, some planetary puzzles, and yeah, we're definitely going to talk about Pluto.
All right, let's start at the very, very beginning. Seriously, how did all of this, every star, every planet, you, me, everything, how did it all come to be? It is just a mind-bending question, right? The entire universe, everything we see, apparently exploded from a point smaller than a single atom. So how in the world do you get from that to us, living on a planet in a galaxy? Let's follow the cosmic breadcrumbs. The time frame here is just staggering. It all kicks off about 13.6 billion years ago with the Big Bang. Then, for billions of years, gravity just goes to work, pulling together clouds of gas and dust to form the first galaxies, including our very own, the Milky Way. And then, much later, only about 4.5 billion years ago, our little corner of the galaxy finally started to take shape. So how did that happen? Well, the best idea we've got is called the nebular theory. Picture this, a gigantic spinning cloud of gas and dust, probably leftovers from an even older star that went supernova. Gravity starts pulling it all inward, tighter and tighter. The center gets incredibly hot and dense until, boom, it ignites and becomes our sun. All the leftover stuff flattened out into a spinning disk where little bits of rock and dust started colliding and sticking together, eventually building up into the planets we know today. And just like that, we've gone from the birth of the universe to our own cosmic neighborhood. So let's take a tour and meet the star of the show and its orbiting family. At the heart of everything is our sun, this massive engine. And you know, its recipe is actually pretty simple. It's almost all hydrogen and helium. The crushing pressure deep inside its core is so intense that it literally fuses hydrogen atoms together to create helium. And that process unleashes the incredible amount of energy that lights up and warms our entire solar system. If you want to grasp just how dominant the sun is, you only need one number, 99%. The sun makes up 99% of all the stuff, all the mass in our solar system. That means every planet, all the moons, every asteroid, all of it put together is just that leftover 1%. That's why it has such a massive gravitational pull. It's the anchor that holds our entire cosmic family together. Now, the planets themselves are organized in a really interesting way. Our solar system is basically split into two zones. Close to the sun, you have the inner rocky worlds, the terrestrial planets, Mercury, Venus, Earth, and Mars. They're all small, solid, and dense. But then you cross the asteroid belt, and you get to the gas giants, the Jovian planets. We're talking about the behemoths, Jupiter, Saturn, Uranus, and Neptune. They're huge, made mostly of gas, and they have all these incredible moons and ring systems. Okay, so let's zoom all the way in to our home turf, Earth. Because all these cosmic movements we've been talking about, they aren't just abstract facts out in space. They dictate the rhythm of your life every single day. The most basic rhythm of our life comes from this number. We call it a day. But if you want to get really nerdy about it, it takes the Earth 23 hours and 56 minutes to do one full spin on its axis. And it's that constant, steady rotation that gives us the fundamental cycle of day and night. The next rhythm plays out over a much bigger time scale, 365 days. That's our year. It's the time it takes for Earth to make one full lap around the sun. Now, this journey is what gives us our seasons, but maybe not for the reason you think. It's not about being closer to or farther from the sun. The real reason for the seasons is this number, 23.5 degrees. That's the tilt of Earth's axis. Think of Earth as a spinning top that's tilted over just a little bit. That tilt never changes as we go around the sun, and that's the secret ingredient. It's all about which part of the planet is leaning into the sun's direct rays. So here's how it works. Around the June solstice, the northern hemisphere is tilted towards the sun. That means more direct sunlight and longer days. Hello, summer. Then, 6 months later, at the December solstice, it's tilted away from the sun. The rays are less direct, the days are shorter, and that's winter. And in between, during the equinoxes in March and September, that tilt is kind of sideways to the sun, so neither hemisphere gets more direct light. That's when we get spring and fall. It's that constant tilt that drives the whole cycle. So now that we're grounded here on Earth, let's zoom back out one last time.
because we need to talk about the rest of the family and dive into one of the most famous and maybe most emotional debates in modern astronomy.
You see, for the longest time, what made a planet was surprisingly fuzzy. So back in 2006, astronomers got together and made an official checklist. 1, it has to orbit the sun. Easy enough. 2, it has to have enough gravity to pull itself into a round or nearly spherical shape. Makes sense. And 3, this is the big one, it has to have cleared its neighborhood. Basically, it has to be the gravitational boss of its own orbit.
And this brings us, of course, to Pluto. It passes the first 2 tests with flying colors. It orbits the sun and it's round, but it fails on that third rule. Why? Because Pluto's orbit is right in the middle of the Kuiper Belt, which is this huge, messy ring of icy objects. Pluto just isn't big enough to be the gravitational boss out there, so it couldn't be called a planet anymore. Instead, it became the poster child for a whole new category, the dwarf planet.
And here's the thing, Pluto isn't alone. It's not some lonely outcast. It was just the first of a new club. Since then, scientists have found other dwarf planets, like Eris, which is actually even more massive than Pluto, and Ceres, which is way closer to us, hanging out in the asteroid belt. So really, this decision didn't demote Pluto. It promoted it as the trailblazer for a whole new class of fascinating worlds.
And all of this really leaves us with a final, fascinating thought. Our map of the solar system, of the cosmos, it's not set in stone. It's a living document that we're constantly redrawing with every new discovery. We know there are thousands of objects out there in the Kuiper Belt and beyond that we haven't even met yet. And that just makes you wonder, what are we going to find next that makes us have to redraw that map all over again?